and example 3. As air expands in a horizontal nozzle, the temperature falls from 400 degrees Celsius to 350 degrees Celsius. If the inlet velocity to the nozzle is 30 meters per second, find the outlet velocity, assuming no heat is gained or lost by the air and no external work done. And we'll take the specific heat at constant pressure of the air to be 1.15 kilojoules per kilogram. Okay, so this is our nozzle, and some of the pertinent information. Then we have the inlet temperatures 400 degrees Celsius, and it's just a good practice to convert that to Kelvin. So we add on 273 degrees. So that gives me 673 degrees Kelvin, and at the outlet is 350 degrees Celsius. So that again, add on 273 gives me 623 degrees Kelvin. The inlet has a velocity of 30 meters per second. We can work out the kinetic energy there, the specific kinetic energy, and we are asked to find the outlet velocity. Okay, so we'll again start with the steady state energy equation, and we don't have the mass, so we're just dealing with specific heat, specific work, and specific enthalpy, and so on. The air expands in a horizontal nozzle, so there's no difference in height between the input and the output. So this value here is going to be 0. So our equation reduces to this. There is no heat is gained or lost by the air, and no external work is done. So there's no heat, so that's a 0, and there's no work, that's a 0, so 0 minus 0 is just 0. Right. The difference, the change in enthalpy is Cp times T2 minus T1, and the change in kinetic energy is V2 squared minus V1 squared all over 2. So I'm just going to plug in my values. So Cp is, so we're told it's 1.15 kilojoules per kilogram. I've brought it all to joules, primarily because the velocity component here will be expressed in joules. So it's better to keep them all in the same units. So it's 1150 times 623 minus 673, so the output minus the input, and that's plus. So we don't know what V2 is, and we know that V1 or C1 is 30 meters per second. Okay, so when I multiply this out, I get 57,500 joules, and I'm going to bring that across to this side. 30 squared is 900, and I'm going to multiply this by 2 and add on 900. So V2 squared is 57,500 multiplied by 2 plus the 900, which I bring across here. That works out to be 115,900. So V2 then is just the square root of 115,900, which is 340 meters per second.